Hello and welcome to dear friends. So today we will be discussing about the simultaneous equation model. In the previous lectures, we have discussed the linear regression model of the form of y is equal to beta 0 beta 1 xi plus ui, where the y is the dependent variable and x is the independent variable. And we have also discussed that the independent variables could be more than one, in which case what we call the multiple linear regression model. However, often we will face a situation where we will have more than one dependent variables where we cannot estimate a single linear regression model. So let us take an example to understand that situation here. So let us consider we have a situation where the stock prices depends on the dividends and the market sentiments. So the stock prices of any firm, it will the theory says that it will depend on the dividend, that how much profit it pays, and also the market sentiments. On the other hand, so that means if the dividend is more, obviously the people will try to buy more and more of that uh, share. So obviously the stock prices move up. So the stock prices may depends on. So basically dividends what reflects? It reflects the company performance. So the stock prices depends on the dividend as well as the market sentiments. On the other hand, theory says that on which the dividend will depend. Obviously, the dividend will depend on the stock prices, because if the stock prices rises, that means it shows the better performance of the company. If the company has a better performance, making the profit, then obviously they will distribute the dividend. So the dividend also depends on the stock prices, and also it depends on the market sentiments. So now, if we carefully look these two equations, so what we can observe, structurally it looks like the same as the linear regression model. However, there is a certain aspect which we are not able to relate like the linear regression model. What is that aspect here? That aspect is here, if there is change in the dividend, so it will lead to the change in the stock prices through this particular equation. However, the stock prices, which is the dependent variable here, becomes the independent variable in equation second. So that means that due to the change in the dividend, the stock prices will change, and due to the change in the stock prices, through equation 2, there will be again change into the dividend. And again that change in the dividend will lead to a further change into the stock prices through the equation 1. So there is some kind of interlinkages between these two equations here, being dividend as the explanatory variable, but at the same time it is also becoming the dependent variable, and same goes with the stock prices. In the first equation where it is the dependent variable, it acts as like the independent variable in the equation 2. So there is some kind of interaction is going on between these two equations, and that this is basically is forming a system of equation. So here we cannot separate one, because if you are separating one, automatically through two it will have impact on the dividend here. So such kind of system is basically known as the simultaneous equation model. So such type of system of equation is basically known as the simultaneous equations model. So that's what we call this. So let us take another example to understand this. So let us take the example of the demand function. So we know that from the economic theory, the demand function is that is the quantity demanded of any particular good depends on its price, and it also depends on the income. However, the market theory says that we cannot find out or determine the demand in isolation. We have to determine the quantity demanded in a situation in the market condition where in relation with the quantity supplied and also in the equilibrium situation. So that means, so this market model says that there should be the combination of the three equations, then only we will be able to determine the equilibrium demand and equilibrium supply. In isolation we cannot determine that. So that means the market model consists the three equations, that is the demand equation, demand function or demand equation, supply function, and the conditions for equilibrium. So we have one equation here, the second equation here, and the third equilibrium equation here. So here what we can observe, again in isolation we cannot do that, because this quantity demanded here, what is it, is the dependent variable, but again through the change we will see that it will have impact in the other equation. So again this system of equation is known as the simultaneous equations model. Now the question comes, structurally it looks like the same like the linear regression model, then why we have the separate discussion on this? We'll see here in a minute that we cannot use OLS in the certain situations here. So why we will not be able to use the system of this OLS, or if we are able to use, do we have to follow a certain specific procedure? So here we have to follow the certain strategy to estimate such kind of system of equations. So that's basically what we are going to discuss today. So this whole system of equations is known as the simultaneous equations models here, and why we are not going to use the OLS. If we are going to use, what changes we have to make. So that's what we are going to discuss today. So before going to discuss that, let us understand the certain terminology which is related with the simultaneous equation model. So the first terminology comes the exogenous and the endogenous variables. To understand that, let's focus on to these two equations here. Now, the stock prices is determined based on this dividend and the market sentiments here. On the other hand, again the dividend is determined using this particular equation 2 through the stock prices and the market sentiments. That means both the stock prices and dividend is being determined within this system of equations. So any variable which we are going to determine within this particular system of equations, those are known as the endogenous variables. So in this specific case here, both the stock prices and the dividend are endogenous variables. However, this market sentiment is not being determined within this system. So then this market sentiments is basically exogenous variable. So here this market sentiments is basically what we have a exogenous variable. Now let us take the second example here. This in case the second example here, what we can observe here in this the second example, that this quantity demanded, it is being determined within this particular system of equations. Similarly, the quantity supplied is also being determined within this particular system, and through the interaction of this quantity demanded and quantity supplied within this system, we will be able to determine the price. That means this quantity demanded, quantity supplied, and price is nothing but endogenous variables, because all these three variables is being determined within the system. However, if you look at the income, this is not being determined within this system. Then this income should be treated as the exogenous variable. So in nutshell, we can say any variable which is determined within this system is endogenous variable, and all those variable which is not being determined within this system is exogenous variable. Now let us say that there is another terminology which we have discussed earlier, that is the explanatory variables. Now if we look carefully here, this dividend and the market sentiment both should be treated as explanatory variable for this particular equation. However, the market sentiment is only the exogenous variable. So by that, there is the relation between exogenous and explanatory variables. That means all the exogenous variables could be treated So all the exogenous variables could be treated as explanatory variables. However, all the explanatory variable may not necessary that it will be also exogenous. So that's the basically relationship we have between exogenous variable and the explanatory variable. Then there is another terminology related to the simultaneous equation model, that is the structural equations and the reduced form equation. So to understand that, let's consider this, the market conditions here. So this is the system of equations where we do have the three equations. In the first equation we represent the quantity demanded, and another is the quantity supplied, and the third equation where the quantity demanded is in equilibrium with the quantity supplied. This form of three equations is known as the structural equations, and the parameters, that is the alpha beta, that means when we say alpha beta, that is both alpha 0 alpha 1 and beta 0 and beta 1. All these four parameters is known as the structural parameters. However, we have the relation here, the quantity demanded is quantity supplied. If we are using these equations and we equate the equation 1 and 2, by solving that we can have the pi in the form of this, where the pi is the nothing, beta 0 minus alpha 0, alpha 1 minus beta 1. So this equation basically we get by using the relation, third relation, where we are equating the quantity demanded with the quantity supplied, and by solving that equation we will get the relation in this particular form. And here now what we are doing, basically we are, this pi 1 is nothing but the beta 0 minus alpha 0 and alpha 1 minus beta 1. Similarly, we have pi 2 is nothing but the beta 2 upon alpha 1 minus beta 1. Similarly, we get the fifth equation of the quantity demanded. So by substituting this pi into the equation 2, and we will get this relationship here. So this, the relationship represented in equation 4 and 5 is basically known as the reduced form of equations, where the pi's are known as the reduced form of parameters. Now, what is the difference between the structural equations and the reduced form equation? Basically, in the structural equations, we are representing the economic relationship in its original form, whereas in the reduced form, we represent those relationships in the derived form. So this is the first difference we have, that in structural equation we represent the original economic relationship as it is. From that we derive the relationship and that we represent into the reduced form equation. But there is another major difference between these two. So if we look here, let us say in the first equation, this quantity demanded is being determined by the price as well as the income, whereas this price is the endogenous variable. However, I is the exogenous variable. Similarly, if you see the equation 2 here, this quantity supplied is determined and being represented in relation with the endogenous variables. However, if we look carefully in the reduced form equations, every endogenous variable is being determined by the exogenous variable only. In both the equation, we can observe that this is being determined only by the exogenous variables. That means in the structural form equations, a particular dependent variable could be the function of both endogenous as well as the exogenous variables. However, in case of the reduced form equations, every endogenous variable or the dependent variable is the function of only exogenous variables. And basically that leads to us in a separate zone and the reason why we are concerned, specific concern about the simultaneous equation model. In case of structural equation models, we will not be able to use the OLS method. However, in case of the reduced form equation, we will be able to use the OLS method to estimate the parameters. So that's the basically the concern why we are reducing or why we are changing the structural form equations into the reduced form equations. Then the obvious question arises, why we will not be able to use the OLS method to estimate the parameters of the structural form equation. However, that we can do for the reduced form equations. Basically, there comes the question of the simultaneity problem. In the structural form equations, we will see there is the problem of simultaneity, because of which we will not be able to use OLS. Now, then question comes, what is simultaneity problem? To understand the simultaneity problem, let's take the example of this equation here. So, in this equation, anything if happens here in the error term, it will have impact on this quantity demanded, there will be change. Let us say the people's taste and preferences has changed, and that has affected in the error term, and through that we have the change in the quantity demanded here. Now, if we look this change here in the graphical form in the equilibrium situation, now what happens here? So this is the initial situation where both the quantity demanded and quantity supplied is at equilibrium, and we have the equilibrium price P0 and we have equilibrium quantity Q0 here. So this is the initial situation we have. Now we have got a certain kind of shock, let's say the positive shock in the error term in form of change in the taste and preferences, and due to which there is the change in the quantity demanded. Now if the quantity demanded has changed, so what impact we will have here? So there is the change in the quantity demanded, so demand curve shifted from D0 to D1 without, there is no change into the second equation or the supply equation. But however, what is happening here? In the equilibrium, both this price as well as quantity demanded, both has been simultaneously determined. So there is change only one, but it has affected the whole system, and both the price as well as the quantity has been changed at the equilibrium. So that's the basically what we have, the simultaneity problem. Okay, there is a change only in one, but due to the being a system of equations, it is changing the other scenario also. Similarly, let us say if you are taking another case here, let us say there is no change into the demand, there is the change only in the supply, and because of the change in this, the supply has decreased. If the supply has decreased, what we can observe here, that equilibrium moves from this point to this point. Here again, we have change in the price as well as in the quantity demanded. So that means either you have the change in the quantity demanded or you have the change in the quantity supplied, but it affects the whole system of equations. So that's basically what we have, the simultaneity problem. If that is the simultaneity problem, then what basically happens? And if there is a simultaneity problem, what is the reason because of this we will not able to use the OLS? To understand that, let's take the example here. So what is the simultaneity problem bias we have? So consider this particular model here, which we have discussed, that the stock price depends on the dividend as well as the market sentiments. And the dividend depends on the stock price and the market sentiments here. Now, let us see what happens here. Let us say there is a change in the dividend. If there is a change in the dividend, the stock price will change. And that change in stock, or there's a say, in general, there is a change into this error term. So due to the change of this error term, we will have change into the stock prices. So let us mark here 1, and due to this we will have change in the stock prices. Now, if there is a change in the stock prices due to the relation represented in equation 2, that is here, due to this, here we will have change into the dividend in equation here, the third step. However, again this dividend is part of the first equation, so that change will reflected here. That means a change in the error term has resulted a change into the explanatory variable, that is in the dividend. That means we might predict some kind of relationship between this error term and this explanatory variables, which is basically violation of assumption of OLS. To understand better, let us see here. If there is the change in the error term, this increase will cause change or increase in the stock prices because of the equation 1. Then if the stock prices increases, then the dividend will also increase because of the relationship in equation 2. Now if the dividend increases in equation 2, it also increases equation 1 where it is an explanatory variable. That means we might predict some kind of correlation between the explanatory variable and the error term. Whereas the OLS assumption is that there should not be any correlation. If there is any correlation, then it will lead to a biased and inefficient estimate. Therefore, due to this simultaneity problem, we will not be able to use OLS estimates into this situation. So, if we are not able to use, then what is the way out we have? To understand that what we have to have the problem of identification. Before, what is identification problem? Let us see here the structural equations of this market model here and the reduced form equation we have here. Now, if we compare this structural form of equations and the market form equations, now because of the simultaneity bias, we cannot use OLS estimates here or OLS method to estimate the parameter beta 0, alpha 0, beta 1 and alpha 1 here. However, we look here the reduced form equation, we do not have the problem of simultaneity bias here because the y is exogenous variable and this endogenous variable depends only on the exogenous variable here. So that means there is no problem of the simultaneity. That means we can use OLS here to estimate the parameters, that is the pi's. Now once we have estimated the reduced form equation pi's, then we have the relationship. That relationship what we have, this pi 1 is nothing but we can represent these in form of the structural parameters here. So that means once we estimate the pi's, then we can go back to get the estimate of the structural parameters. However, it will not be possible always to go back to from reduced form parameters to the structural form of parameters of the structural equations. Why? So let us take the case here, in this case here. So how many parameters we have? Here we have the 2, that is the pi 2 and the pi 4 here. So the pi 1, pi 2, pi 3 and pi 4 we have in this equation here. Now how many parameters we have? We have the 4. And how many in structural parameters we have to estimate? That is 4, that is alpha 0, beta 0, alpha 1 and beta 1. That means we will be able to estimate the parameters, but that will not be always situation here. Sometimes it is difficult to go back from reduced form parameters to structural form of parameters. So when we are able to go back, when we will not be able to go back to the structural form parameters, so that's what we call the problem of identification. Now, there will be three possibilities. One possibility is there is entirely we will not be able to estimate the structural parameters from the reduced form of parameters, or there could be that possible to go back in a unique way, or there are more than one way to go back. So the problem to get consistent estimates of the structural parameters from the reduced form coefficients is known as the identification problem. Now, whether we are going to able to go back or not, depending on that, we have the three types of identification. So what we have under identification, exact identification and over identification. Under identification means we will not be, it is not possible to estimate the structural parameters from the reduced form of parameters. Exact identification means there is the unique relationship between the structural parameters and the reduced form parameters. Over identification means there is more than one relationship between the structural parameters and the reduced form of parameters. Now, identification, how we will identify those. So let us consider this here, the situation of this equation here. Now, reduced form parameters of equation are the pi 1 v1 and pi 2 v2, where we have the pi 1 is equal to this here. Now, in this situation, what we have the two parameters, that is pi 1 and pi 2 for the reduced form equation. However, how many structural parameters we have? For structural parameters, we have alpha 0, beta 0, alpha 1 and beta 1. So we have four unknowns. However, how many? We have the two equations. One equation is this, another equation we have this. So we have this and this, that is the two equations. So that means 4 unknowns and 2 equations. And from the basic algebra, we know that we cannot identify in such situation. We know at least the same number of equations as many as there are unknowns. However, here we have more unknowns and less equations. Therefore, it is not possible to estimate the structural parameters using the relationship between the reduced form parameters and structural parameters. So, this is the situation what we have under identification. So, this is the under identification. However, it is not always easy to use such kind of mechanism to ascertain whether there will be under identification, exact identification, or over identification, specifically when we have large number of equations. However, there is a systematic pattern study, systematic approach through which we can identify, and it becomes easier. So that systematic approach is basically what we know as the conditions for identification, which basically have the two-step procedure, or we have the two uh, conditions. The first condition is known as the order condition. Second condition is known as the rank condition. So let us define here certain terms before using this. So G is the number of endogenous variables in the system. M is the number of variables, whether it's endogenous, exogenous, lagged endogenous, missing from the equation under the consideration. So G is the number of endogenous variable in the whole system, whereas M is the number of variables, whether it's endogenous, whether it's exogenous, whether it's lagged endogenous, from that particular equation for which we are going to put to the test. Then the order condition says that if M is less than G minus 1, the equation is under identified. M, that is the number of variables which is missing from the equation under consideration, is less than the G minus 1, then the equation is under identified. If the M is equal to G minus 1, the equation is exactly identified, and if M is more than G minus 1, the equation is over identified. To understand better, let us see here this. However, this order condition is necessary but not sufficient. So, until unless it is satisfied, we cannot go to the next condition. However, if it is satisfied only this condition, we cannot surely say there will be the identification under or over identification.